Okay, welcome back to part 3 of this series of remaking the Asteroids.js site video game that I did last year, which wasn't very good. Watch part 1 to see my explanation of that. So I wanted to redo it, introduce a few new little things as well, remove the Vue.js mid layer, which we just didn't need at all. As you can see, if you followed along up to now, we've got as far as we did almost without Vue.js at all, without even using npm for that matter. So it's been wanted to do this earlier, but I'm glad we're doing it now. So this video, the first two, we did the setting up, created the ship. Second video, we created the shots and put the edge detection on. Now we're going to create the asteroid and then put the collision detection on the asteroids. So let's get started. So the first thing we want to do is create an asteroid class. New file, asteroid.js, and as always, go to the index file and make a reference to it there. Asteroid.js. So you remembered in the last video we introduced this idea of extending now from the obj class so that we could get this edge function, because all three things, the ships, the shots and the asteroids, all go off the edge and come on the other side. Excuse me. So by simply adding that on now as a extends here, it just inherits that equals, no. It just inherits that edge function now, just like that, just by magic. I mean, we won't be able to do it with the other functions as well, but the other ones are very bespoke, you know, how it draws itself and how it moves and that. But the movement we might be able to do, but anyway, we'll come back to that. So we have our asteroid class. So similar to the shots, the asteroids are created in an array because there are more than one. So let's just create an array, asteroids. I tend to put arrays as plural and single objects as singular. It's a general convention you'll see programmers do. So the thing with the asteroids is they're created at the beginning, not by anything the user does. They need to be there at the beginning. So if you look at the one I did the other day, the code I did the other day, again explanations on what this is in part 1, you'll notice I set the asteroids up here in the setup function, which is only run once. So I need a variable that says how many asteroids are we going to create. So let's put that in. Const asteroid count equals 10. And then you'll notice I do this loop here, which builds the asteroids and pushes them into that array. So let's just copy this out, and then we'll explain it. So we loop from 0 to asteroid count, which is in this case is 10. We actually loop to 9 because we only loop while it's less than 10, but 0 to 9 is 10, so that's where we get our 10 from. And that the a++ means add 1 every time. So a equals 0 all the way through to a equals 9. Then we say asteroids.push, which basically means, as you see, appends new elements to an array. So whatever's inside the push argument here will get put into this asteroids array here. So we're saying create a new asteroid object from the asteroid class that we've just set up, and the initial value that we pass in, or values, is a random value based on the width of the screen, a random value based on the height of the screen, and the number 1. So we know we need to pass in 3 parameters, and we'll explain them in a second. So let's go into the asteroid class. So we need to set up a constructor. So we said we're passing an x value based on the width, a y value based on the y, and a value stage. We pass in the value 1, which we're going to call stage. Now you'll remember from the last video we have to call the super function just to appease the inheritance gods, and then we can set these x and y as things to do with the asteroid, so like we did with the ship and the shot. So let's do the position, which is a standard thing. We create a vector. So this dot position equals create vector x and y. Yeah, so that gives us our position as a vector. That's fine. What else have we got in here? This velocity. Let's copy that line. So this velocity equals create vector, similar to the position, but we're giving it a random value in the x position and the y position of anywhere between -1 and 1. Now, from the previous videos, you'll remember that when we were capturing the key press of the ship, the key press itself was determining the direction by being a -1 or 1, or a 0 for no direction, for no movement, but it wasn't controlling how much the ship moved. We left that to somewhere else. And this is sort of similar, but not in the sense, as in, we're giving these asteroids at stage 1 a maximum speed of 1 by the fact that the value is a random value between 1 and -1. So we take this x1, for example. So we know x is left to right. So if the value given from that random result was 1, then its movement will be on the x-axis 1 every frame. But it's likely that it's going to be somewhere between 1 and -1, not 1. You know, the probability is obviously low. So if it got a probability of 0.5, a value of 0.5, then it would only be moving every a pixel every other frame, because it'd be running at half speed. If it got a value of -0.5, it'd be running left at 2 pixels per frame. No, sorry, 2 frames per pixel. Yeah. So, and the same for the y-axis. So then we get this random. Each asteroid gets a random velocity in one of the 2 axes. You combine them together and you get an asteroid that's moving around at a maximum velocity of 1 in any given direction, but more likely to be less than that. And so each asteroid gets its own combined xy value to move in that direction. So that's what this velocity is. Okay, so the stage, yeah, we need to set that as well. I'll explain that. So this, just saying this dot something, so this dot stage means this is now the value associated with this particular asteroid, and you know, whereas stage was actually just what was passed in. If I don't assign this, then at the end of this function that value is lost and I can never use it again in this asteroid, so I just assign it to a local asteroid variable. Yeah, same as I've done with these. So we keep the stage value, we'll come back to that in a second. We need to set the points, so we hard code them, we hard code the noise, and we have an offset array. So let's copy them 3. Okay, so what are these? Well, let's go back to the original one. Let me just crash the ship so that we can see what's going on. There we go. So I'll just zoom in here to this asteroid. So if we start here, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4. Oh, there's one there. Yeah, sorry. 5, 6, 7, 8, 9, 10. So we have 10 points around this particular polygon. So that relates to this point here. This number of points on any given asteroid is 10. So what about noise? Well, if you look at this, let's think of this way. I wish I could do an on-screen drawing here. But the centre of the circle that this polygon is based on is here. Now I left the circle in on the original one for collision detection, as I did with the ship. So a collision occurs when the overlap occurs here, and it seems that, you know, in a frame it's moved 2 pixels in, 2 or 3 pixels in that frame, and that's triggered the detection. So if you can imagine the middle of the circle here, and if you can imagine a radius going out to each of these points and beyond, so from there to there, from there to there, from there to there, from there to there, and so on and so on. If basically the noise is, if the point lands exactly on the circumference, so if we drew a radius out here and it the point was there. It's close to where that one is there. But if it was actually on the circumference, then there would be no noise. That would be a zero noise. So what the noise does is it pushes the point that's actually drawn to in a given direction, either away from the radius, or sort of away from the centre of the circle along the radius, or towards the centre of the circle along the radius. So this one, for example, the middle's here. The circumference point in reality for the circle should have been there, but it's all the way in here. So this noise, this random value for each point, has been brought in, and by simply doing that by a number of points on the edge, you get this random polygon shape, which is great for, you know, a simple asteroids game. And that's all what's happened here. So the noise means 20 pixels in either direction maximum. Okay, so we're going to initialize that now. I'm going to copy the code here because it's quite, as you can see, it's quite lengthy. I'm just going to copy this one first of all, and we'll explain what the stages are. So remember, the stage was the third parameter passed in, and when we create the asteroids at the very beginning, that's a 1. So the first time the asteroid's created, we do a 1. So if stage equals 1, which it will be first time round, we set the radius to 50, the velocity we set to this random value, so we don't need that anymore, and the noise we set to this value, so we don't need this anymore, because now we're setting it in here. Now, the reason why we have stages is, as I shoot, if we play this game, need to set it so it's not as detrimental to start, but if I what's the arrow keys for this one? The original polygons are based on a 50 pixel size radius circle, but once I shoot it, it breaks up into 2 smaller circles, so they're stage 2. So now we say, well, if it's stage 1, it's this size, but when we destroy that asteroid, we create 2 new ones that are smaller, and they're stage 2. So if they're smaller, they get a smaller radius. So we can put that as a condition here. Stage equals 2. So we can set a smaller radius. 30. We can set a faster velocity, because obviously they go faster, or can go faster. So we can say, rather than random -1, 1, say random -2, 2. This velocity is now a value of -2, 2 to -2, so we can say random -2 to 2 on the y-axis. Now, because the noise, because the radius is reduced, the noise doesn't have to be as big. So we can, what did we set it to? 20, 3/5. So we can do that to 12, same proportion. Okay, and then finally we go to the smallest asteroid, the third one. So if stage equals 3, then the radius is 10. We'll set the speed to 4, or up to 4, and the noise is 4. So we don't really need to do that much noise on that small ones. Cool. So that covers this. Now, so we need to generate the noise now. So remember, the noise is, we go to the, okay, the noise is basically how much off the circumference each radius point is, either plus or minus. So now that we've got the value of the noise, depending on the size of the asteroid, and we've obviously got the radius, so we can set an offset. So remember, here we had an array of offsets. This array is going to keep track of each radius and how much each radius has been adjusted according to the noise. So we loop through each of the however many points there are. In this case there's 10, and then the offset for each point is a random amount based on the noise, plus or minus the noise, and the noise was set based on the size of the asteroid, so it should all work out great. So that gives us our asteroid. So we now need to show the asteroid. So if we we need to move the asteroid first. Let's just copy this. Very similar to the functions we did in the ship and the shot. We're just adding the current velocity to the position, and remember the velocity has been set based on the size of the asteroid. So for every frame you just add that. That's straightforward enough. And now we need to show the asteroid. So now remember, we don't need the edge anymore. So you see on the last one that I pulled the edge in, we don't need that, but we do need this show. And you'll notice that I've sort of got some stuff commented out, and it's a lot more abbreviated code. So let me copy this and explain what's going on here. So imagine, let me bring up a Pythagoras. You probably know this. So you can see from this video here, we have a right angle triangle. Let's call this one the adjacent. It doesn't really matter because normally that's in relation to one of the other angles. So if we were looking at this angle here, this would be the adjacent. This will be called the opposite because it's opposite the angle, and this will be called the hypotenuse. Okay, so don't worry, we're not going to delve too far into trigonometry, but it is important when we're looking at a grid-based system of movement. So as you probably know from Pythagoras' theorem, if you take this length and you square it, if you take this length and you square it, this length squared equals the same area as these two areas added together. So the square of the hypotenuse is equal to the sum of the square of the two other sides. Two adjacent sides? Yeah. Anyway, that's what it means. Now the reason why that's important is on an XY grid system, if you want to work out the distance of one thing to another, Pythagoras' theorem is a great way of quickly calculating that. You could go into the angles, you could go into sine and cosine, but when you're dealing with what the game we're doing with asteroids and you want to work out distances, this makes it much more easier, because what we can say is, see, this is just an abbreviated version of all this, so let me just explain all this out and then you can see why. We'll come back to this in a minute. So what we've done here is, let me just isolate this out. There we go. So let's start with the first one. We take the x length, which is, now remember we're checking. Oh no, this is the hit function. Oh, forget I said that. We'll come back to this in a minute. I've copied the wrong one. I do need to do that, so we'll come back to that in a second. That was silly. There we go. So let's copy the asteroid show method. We will come back to that in a minute. So, similar to the ship, we push and pop so that anything we do in here, i.e. mainly the translate and things like the stroke width and height, don't affect any other part of the code. So with the asteroid, we translate to this position, set the stroke color and the stroke weight, and the fill, which is black, but with I've put a 40% opacity. That might be to do with the circle that I had, the collision circle possibly. We'll come back to that later. Anyway, so then we have this beginning shape, end shape, and this basically means this could be substituted for ellipse and then just parameters, or line and then some parameters. But by doing begin shape, end shape, it means we can customize the shape that we build. It doesn't have to be a fixed sort of polygon or whatever. And obviously we need that for our asteroid. So what we do is we loop through the number of points that we have, which remember is 10. So this is going to create 10 loops for us. We then need to check the angle of the radius. So for here, for example, we need to check, let's say this was point 1, we need to check what angle this is, because we need to do that because we need to know where to draw the point. Okay, so the angle, we worked that out, which is basically, we said earlier 2 pi is a full circle in radians when you're measuring it. So we're mapping 0 to 10, we're mapping from 0 to basically 360 degrees. So that, what that means is that every point is going to be a tenth of this. So effectively each point is going to be 36 degrees, and that ultimately translates back to telling us what that angle is, depending on which point it is. So that's basically what this map function does. It just translates 360 degrees down to 10 points and gives us the angle for each one. So we have an angle. We then want to draw. Now, there is a little bit of trigonometry here. If I took this out, if I took this out and this out, okay, that is basically saying that would give me the x value as if it was drawing a circle normally, no modification to it. So it's basically saying take the radius of something, and if you apply the cosine to it, then it will give me where that x value should be. But without any modification, that is just going to be on the circumference of the circle that it would have been. So nothing's changed there. So behind the scenes, the circle function, or the ellipse function I should say, basically does this. By showing it like this, it means we can manipulate it. And it's the same with the y. The y function, the sine of the angle means that it would just simply put it on the circumference point of that particular angle, whichever way that radius is pointed. No modification. But we've added in the radius, the offset. Remember, the offset was built up of the random noise earlier. So now the x and the y are going to be modified based on the amount of noise that the radius. So we're now saying the radius, and then plus or minus some noise. So if the radius is that far to the circumference, but then we plus or minus noise based on what's in the array, then we apply the cosine or the sine function to work out what the value should be. And that then gives us the x of the modified distance and the y of the modified distance, which means now simply we plot the x and the y as a vertex on that shape, and that gives us the modified shape. We then close off the shape after the 10 loops, and the close function means it draws a line back to the beginning point, so it seals it off completely. And then we draw that collision detection ellipse around that, just so that we can, for our own benefit as well. So that's the show function. So I'm now hoping, let me just check we've implemented this in here. No, we haven't showed the asteroids here, so let me just see how we did that in the other one. Wow, so the asteroids is a big one, and that's because we've got all this collide stuff going on and the hit stuff going on, which we'll talk about in a minute. So let's just make this easy for a minute. Let's just say sketch. So they're the shots. Actually no, we'll just call that ship. So we'll put the asteroid after the shots and before the ship. Okay, so let's paste the beginning of that loop, close that loop off. Okay, so we have our asteroids loop, and easiest thing to do at the minute is just go asteroids a dot show. Okay, so let's see how that looks. Asteroids is not defined. Asteroids. Oops. Asteroids. Anyway, okay, so here we go. So it's drawn our asteroids, and if you look carefully, it's drawn our collision circle, which is cool. So it's drawn our asteroids with the various noise in, that's cool, but they're not moving. So remember, as with the shots, we need to do a move. So let's add that in. And there we go. So we now have movement, but we have no collision with the shots, and we have no collision with the ship. So just need to tidy that up. So you saw all that other code in the one I've done previously, so you can sort of see where we're going with this now. So let's have a look at that. So that was in the sketch one, wasn't it? Okay. So we do move. Then we check a collide. Okay. So for every asteroid, once we've moved it, we need to check if there's a collision with the ship. Yeah. So we need to check if it's now collided with the position of the ship. So let's create a collide function. Asteroids a dot collide, and remember it's passed in the ship's position and the ship's radius, so we can use these to do our Pythagoras stuff that we talked about earlier. So we want ship dot position, ship dot radius. So where's that all suddenly indented? There we go. Oh. Ship dot position. Oh no, what's going on there? There we go. Okay, let's just check any issues with that. Yeah, so collide is not a function, we now need to create that in the asteroid class. So let's go above here, let's go asteroid.prototype.collide equals function, and we passed in the ship position and the ship radius. So how does the collide function work? So we have this dist function, which is a P5 library, and it basically just it simplifies the Pythagoras theorem for us, because it takes the x and y of something, the x and y of something else, and works out the distance. So do you remember we were talking about this earlier? Imagine if that's the x and y of one thing, say the ship, that's the x and y of the asteroid. Well, we can work out that distance by, if you add, we'll know the x amount and we'll know the y amount. So if we square them and add them together, we get this amount. So then if we square root this, we get that amount. So we can work out the distance between 2 points using Pythagoras theorem. That's why I wanted to bring this up and show you. But it's no point going into any major detail because the P5 library gives us a convenience method that does it here. But I was just going to sort of explain out, that's what I was working out here. You get the lengths of the x and the y, you square them, you square the hypotenuse, and you check if one is greater than the other. But this method here just massively sort of just eliminates all that working out for us. So we can copy out this, and so we say distance equals the asteroid's position x and y, the ship position x and y, ship pos, I've called it, haven't I? Where's Okay, X and Y. So then the radii, so both radiuses added together, is this radius plus the ship radius. If the distance between the two positions is less than the two radii added together, no loop just basically means end the looping, which is effectively saying end the game. We need to put some more better stuff in there. But what we're saying is, if the distance between the two center points of the ship and the asteroid is less than the distance of the two radii added together, then we know there must be a collision. And that's why we have the collision circles, just to make it easier for the game to understand why they're there. Because otherwise, if you were to do it on the shape of the asteroid, it might not quite collide. So we just use them as collision things just to make it simplified. So let's run that. And okay, so nothing's happening there. So we mustn't have implemented it in our main sketch. Well, we did. We did a collide. Collide. And that should run a no loop. Okay, let's see what we've done wrong here. Let me reload that. Oh, what I am noticing is the edge function's not worked for the asteroids. Let's have a look at that. I did extend the object I called super. Oh, I didn't call it here. So asteroids edge. So hopefully they'll come off the edge and on the edge. Yeah, so that's fine. But the collision, no, there's no collision. Okay. Let's have a look at this. That looks fine. That looks fine. So asteroids edge dot collide, asteroids a dot collide. So what we'll do in the asteroid class, let's go to the collide function. Let's just do a console log of the radii and the distance. See if that sheds any light on what's going on here. Oh, it has worked now. Oh right, okay, it's being a silly billy. So now we reload that. I should be able to, let me just zoom in. I should be able to collide. Yeah, collide. Now I don't draw the circle around the ship, so that's hard to see. So let me just put that in. If I go to the ship class, so what we're going to do is put an ellipse in here. Now, oh, what have I just done? Ellipse in here. Now, where can we do this? We're drawing the triangle based on 0, 0. So we said this dot radius, wasn't it? I'm not sure whether it centers on the circle for the 0, 0. So we might have to adjust that slightly. But let's have a look. Let's load that page. Yeah, I'm not seeing anything there. So let's just this dot radius. Do we have to do that twice? Maybe. Oh, okay. So the radius is, it deems the total width of the circle, which is why it looks half the size. So we just need to multiply that by 2. Okay. So the circle is drawn, but obviously it's blocking out the view of our ship, which is no good. So what we'll do is we'll put it behind the triangle, but we'll put it behind the stroke and fill for the triangle, and we'll give it its own stroke and fill. So for the stroke, we'll just put a faint blue, which will be RGB, and then we'll run at 40% opacity on that. Fill doesn't really matter. I suppose that could be the same for both. Let's see how that looks. Oh, okay, that didn't work quite how I wanted. So stroke. Okay, let's take the opacity off. Maybe I didn't like that. No, it's like whatever I've drawn here. So stroke, to translate. Let's put all that inside after the translate. There we go. No, I need to fix but that the asteroid doesn't start where the ship is, but for now, not an issue. But there we go, we have our circle of sorts, that's our collision circle. And yeah, so okay. Let's just give it a different colour. Ooh, why is that on that? Let's just give it a different colour. Let's give it a red colour. Some translucence on that. No, it doesn't like that. I thought opacity was the fourth one on the stroke. Maybe it only works for the colour. Oh, I was under the impression you could put like a faint transparency. Sure, what did it do with the asteroid? Stroke 52. Oh, is the opacity up to 255? Is that what it is? Let's try that. So if I do ship.show, so we want red, so let's say 200. Yeah, that's what it is, yeah. Okay, cool. So that works, and the collision with the ship works, with the asteroid. So as I said, we're using the circle as a collision indicator, for a visual indicator, and for the code to determine a collision, just because of the complexity of trying to make a polygon work in a browser environment. Once you start getting lots of asteroids and lots of objects, it's far more complex to work out. So I'm happy with this. As long as the collision circle is there, I'm happy with this as part of the game. I don't even know if the original game did it like that. Excuse me. So the one thing left to do now then is the collision of the shots. So when we fire the shots, so we load our game. I don't know why that one wasn't working, I've killed it somehow. So when we load our game, when a shot hits an asteroid, the asteroid breaks into the smaller ones. So let's go back to R1. At the minute, if I shoot an asteroid, nothing happens. So in the Rocks 2, I did another method so I did collide, which is if a ship hits an asteroid, but I also did hit, which is if a shot hit an asteroid. So that's what this is. So let's copy this one. As you can see, a lot of it is copied out, so we're not going to use the majority of it. So there's our collide function. Let's just put it below our collide function. And now we have our hit function. So we pass in the shots. And again, we use this distance method, this dist, the P5 function, which just simplifies the Pythagoras theorem thing. You can see here I originally did it all manually. Worked out the length of the two adjacents, squared them, squared the hypotenuse, worked out the difference on that, and we might as well just use the built-in method of this. That, you know, once you've learned how to do that, there's no point knowing it still. So we can just use the built-in P5 library for that. So we can get rid of all this commented out code. And let's just check the logic here. So if let's see, so for each shot in the array, this is for each asteroid, we work out the distance to be xy, which is the position of the asteroid, and shots s, x, shots s, y, which is the position of the shot. If it says if this dot radius is greater than distance, so distance is the distance between them, if the radius of the asteroid is greater than that, we return now we return s. So that's basically saying the index of the oh, I see. So that's returning the index of the shot in the array that's hit this particular asteroid. So now in the calling code we can do something with that shot, because in the asteroid class we obviously want nothing to do with doing anything with the shot, but it does tell us which one it is. So we pass that back to the handle hook to the calling code, and the calling code will do something. So and we don't need to add the radius of the ship like we did with the collide method. We added up the ship radius and the asteroid radius. In the hit method we don't need to do that because the shot doesn't have a radius. We just treat it as a single point vector on the screen, so there's no radius with that. It's just its position will class as its radius. So all we're checking for is the radius of the asteroid, if that's greater than the distance, which means the shot has overlapped into the asteroid radius, which means a hit has occurred. So we return that, otherwise after we've looped through all the shots we return false. So let's call that hit function in Sketch. So we have collide, so we might as well put it after that. So hit, and we passed in the shots array. Okay, and however we returned the value of a shot if there was a hit. So we need to check if that method does not equal false. In other words, if a shot collision or hit, let's get the terminology right here, if a shot hit the asteroid, then we return back, as we said in the asteroid class, we return back the index in the shots array of which shot it was, because now we have to do something with the shot and with the asteroid. So there's two things we have to do, well, two main things. There's a number of things we have to do. So number one, we have to add 2 new smaller asteroids if stage 1 or 2. We need to remove this asteroid, and we need to remove this shot. Okay, so that's if a hit has occurred. So let's have a look and see how I did this in the other code. Okay, so yeah, quite a little bit of complex code here. So let's copy this over and let's see how we did all this. Okay. So first of all, we're defining a value of shot index, which is the yeah. So we're not actually just checking if, yeah, this is actually going to replace that code. So let's bring that in here. Let's just push them up there. So we need to comment this out as well. Okay, so we're going to get asteroids. So we're calling this hit method here like we did there with the shots array. But we're going to assign the result of that to the value of the shot index. Now remember, if there is no hit between a shot and an asteroid, it's going to return false. Otherwise, it's going to return the index in the shots array of the shot that has hit that asteroid. So that makes sense. So we need to assign that to a variable so that we've got a reference to it. Now if it's false, that's fine. We've got an if statement here if it doesn't equal false, so let's go back down to the else. If it is false, everything stays as it is, the shot's intact, the asteroid's intact, so all we have to do is show the asteroid. Absolutely fine. In fact, if I comment all that out, this should still work as it did. Obviously the collision won't work. Oh, hit is not a function. I thought we put asteroid hit. Asteroid.prototype.hit. Oh, we haven't saved it, have we? Okay. So everything's fine. The bullets will still go straight through because the hit function doesn't do anything if there is a hit. But it shows that that's as it was. We've just put this extra criteria in, this if statement. But if it goes to that, nothing's happening, and then it just carries on showing in the next time it draws the frame. So no change. So let's break this down. Let new stage equals asteroids A stage. So if it's a first stage asteroid, like the big one at the beginning, that's going to come back as 1. If it's not, it's going to come back as 2 or 3. So what we're saying is, if it's less than 3, in other words, if we can still create small asteroids from the destruction of this one, then we need to create those 2 new asteroids. Otherwise, we don't. We just remove the current asteroid. So if that's the case, if it is 1 or if it is 2, we need to add 1 to it. So now it becomes 2 or 3, respectively. We then need to create 2 new asteroids. So let's just check the first one, and then we'll just copy it to the second line, which is commented. So we push this new smaller asteroid. So we create a new asteroid. We get the current position of this asteroid, asteroids A, and we put the position X and the position Y, because that's the 2 of the 3 parameters it needs, and then we put the new stage in as the 3rd parameter. So remember, new stage has been incremented by 1 here, so if it was 1, it's now going to go in as 2, and if it was 2, it's now going to go in as 3. But we need to create 2 asteroids from that, so let's uncomment that, and everything's the same. So we create 2 brand new asteroids, same spec. However, each asteroid is going to get its own velocity, as in which direction it goes, because the constructor will be called obviously 2 separate times for 2 asteroids, and each one is going to get its own random amount and random direction. So we can still guarantee that they're not going to get the same, or we can't guarantee, but the probability is very small. Good, so that creates our 2 asteroids. Also though, we need to, no matter what happens, if an asteroid is hit, we need to remove that asteroid. So the way to do that is to take an item out of an array at a certain point. You use the splice function. So you take the asteroids array, we splice it at A. Now remember, A is the current asteroid we're in the loop of the asteroids. So at that point we take that out, this asteroid, and we take 1 out, because obviously we're only deleting 1 asteroid from the array. Okay, so it's now saying we need to take the shot out of the array as well. Yeah, I think that makes sense. We can uncomment that. So we splice the shot at the shot index, because the shot has hit the asteroid, we can remove that from the array as well. It no longer needs to carry on, so that can be taken out as well. Now just one more change we need to make here. So we've covered all of this now, and it's something I've mentioned a few times in this series and in other videos, is when we are looping through an array and potentially removing items from the array, it's always good to go through the array backwards, because if you go through forwards, when you remove an item, everything ahead of it changes position by 1, and then your loop starts to mess up, and it just becomes easier to go backwards. Because if you go from the end of the array and head towards the beginning, every time you delete an item from the array, it's all the items you've already been on that move, nothing that you've yet to go to move, so it doesn't alter the rest of your code. So it's just a general convention that you will find yourself doing. So rather than saying a equals 0, we'll say a equals length -1, because arrays are 0 based, so you need to -1 off the number. So while a is greater than 0, greater or equal to 0, because 0 is a valid array index, and then we just want to go a minus minus. In other words, we want to minus 1 of each value until it gets to 0. Cool. So that's it. That's the asteroids array. Theoretically now we run this. Yeah, let's run this. Oh, collision. Oh. Right, some clear space. So we know the collision works. Let's see if the shot works. There we go. So immediately when we hit that asteroid, I aim for that one by the way, missed it. But if we hit this one, and we're getting 2 more asteroids that are much faster. Okay, so let's do that, and then so we hit the smallest one, and then we got an error. So what happened there? Property show of undefined. So what have we not done here? Asteroid show. Oh, we've got. Oh, right. Okay. If we delete the asteroid, we don't need to show it, do we? So we can leave that one inside the else statement. Okay. Let's try that again. So let's get some small asteroids here. There we go. Now that is going slow, but potentially the random value allows it to go faster, and you can tell that from this one here. But it just so happens that the random value is a lot slower for that. Now what we could do is possibly put a minimum value in for the smaller ones so that it goes at least a certain speed. But I mean, that's something maybe you could handle on your own going forward. You could, rather than just put a random value, you could work out how to do a random value within a range rather than just a random value. But I would say, looking at that is done with regards to remaking what we made the first time round. So that is excellent. That I am. Whoa, it's getting hectic now. It's actually quite good to play. I think I might just do another video at some point just to actually polish this up and put the score on, and maybe make it increasingly difficult or something. Yeah, I might do another video at some point and add on to this, but this is enough to get you the game playable, at least with a ship and all the collision detection, and maybe take it a bit further, see what you think. So that's it. That concludes our series of 3 videos in rebuilding this JavaScript version of Asteroids that we built last year but desperately needed a makeover. So this is the 3rd part of 3. If you haven't watched the other 2, please go back to the playlist and have a look. If you liked this playlist and these videos and you want to see more of this kind of stuff, please click the subscribe button under the video. Really do appreciate that. And obviously if you like this particular video, click the like button, and as I say always, it just gives me a good indicator that what I'm producing is the kinds of stuff people like yourself want to see. So I've got some other stuff on the go. I'm still working on the massively multiplayer version of this using sockets, web sockets, and still going through some theory stuff on that before I come back to that. I've also got an ongoing playlist for creating accounting software in Laravel, which is a PHP framework. A bit more of an intermediate one, but if that you think is something of interest to you, again, check out my channel and you should be able to see that playlist in there. And I'm going to try and find some other game ideas from my childhood and see if I can reinvent them into modern JavaScript versions as well. So hopefully you've enjoyed all this. Thanks very much for watching, and see you next time.